Welcome back to the Best PT Podcast. This is episode 35, Evidence-Based Practice. Let's talk about PICO, P-I-C-O. The P, patient or problem. What is the problem or patient population of interest that's being researched? I, intervention. What intervention, diagnosis, or prognosis are we trying to evaluate? Comparisons, C. What control treatments or placebos will we be comparing the experimental intervention to? And outcome, O. What changes or results are we measuring, and how will we determine if they're effective? Talking about levels of evidence from top to bottom. Systematic review, a comprehensive review of the medical literature that focuses on the methodology, specifically about research on a specific topic. Meta-analysis is a systematic review that uses statistics to determine an estimated effect size by combining the results of several different randomized controlled trials. So the theory here is that by pooling small sample sizes from multiple studies, we can calculate a larger estimated effect size. A randomized controlled trial, or RCT, is an experimental research to assess the effect of a specific variable compared to control conditions. A cohort study is a longitudinal, observational study that compares occurrences of a disease in exposed groups to unexposed groups. Case control study. These are retrospective observational studies that look for an association between exposure and occurrence of a disease. This is also called the odds ratio. Cross-sectional studies. All subjects are studied at the same time. These are used to describe the prevalence of a disease and demonstrate associations. These studies cannot distinguish between incidence and prevalence or establish causal relationships with the disease. Case reports or case report series. These are descriptions of an individual's conditions and their specific response to treatment. These cannot test hypotheses or establish cause and effect relationships. Different types of research. Descriptive research is for the purpose of classification and understanding clinical phenomenon. This includes developmental, normative, and qualitative research, as well as case reports and case series. Experimental research is a comparison of two or more conditions to determine cause and effect relationships. Exploratory research examines the characteristics of a clinical phenomenon and its relationship to other factors, so cohort and case control studies and historical research. Different types of data. Continuous data are data that can assume any value on a continuous scale, so range of motion, distance, weight, time. Discrete data is data that's measured in whole units only, so heart rate, number of patients with a diagnosis, or number of PT visits, so you never get a decimal version of a heart rate or number of PT visits. Dichotomous data is discrete data limited to only one or two values, so yes or no, basically, one or two. So male, if the patient is male or female, if they're a smoker or non-smoker, that's dichotomous data. Qualitative data is categorical data, such as eye color or blood type. And quantitative data is data that represents counts or measurements. Speaking of measurements, we have different scales of measurement. We have nominal measurements. These are values that are mutually exclusive and qualitative, such as blood type or eye color. Ordinal measurement are values that are ranked. So manual muscle test grades or levels of assistance. These are ranked values of measurement that have a fixed bottom and top as far as grading goes. Interval measurements. These are intervals between values that are equal but have no true zero. So a good example here is temperature. Temperature can be below and above zero. And ratio measurements. Intervals between values are equal and there is a true 0 point. So distance walked is a good example. You can't have negative distance walked. It's either 0 or some sort of positive measurement. Moving on to reliability. Alternate forms reliability looks at the consistency and agreement of measurements obtained with different forms of a test. Internal consistency is the extent to which items or elements of a test reflect one basic phenomenon. Intra-rater reliability looks at the consistency of repeated measurements made by the same person. Inter-rater reliability looks at the consistency of measurements made by more than one person. Test-retest reliability consistency of repeated measurements made on the same subject on separate occasions. Validity, different types of validity. Face validity, the degree to which a measurement appears to test what it is supposed to. Content validity, the degree to which a measurement reflects the elements of an idea. For example, the McGill pain scale has more content validity than a simple numerical pain scale because in addition to measuring pain intensity on a scale of 1 to 10, it also asks about the location, quality, and duration of the pain. Construct validity is the degree to which a construct is measured by a test. Criterion-related reliability is the validity of measurements established by comparing it to a gold standard measurement. So if there is already a well-established, well-researched measurement, that would be considered the criterion measurement that would be compared to. Sampling. Population sampling. So the group that the results of a study are targeting for generalization is considered the population, while a sample is a subset of that population, and it's used to make estimates about the whole population. Stratified random sampling is a random quota sampling of subgroups. Systematic sampling. Subjects are selected by choosing every X person. Cluster sampling is usually used when geographic clusters are surveyed and then a random sample of those clusters are taken. Convenience sampling. Subjects are convenient for the researchers to obtain regardless of demographics or randomness. And snowball sampling is used when characteristics being studied are rare and difficult or expensive to procure. So this occurs every day. I'm sure your inbox is full of emails for surveys or social media posts to take a survey. That's snowball sampling. Moving on to experimental designs. Clinical trials test methods of screening, prevention, diagnosis, or interventions of a particular disease. Completely randomized designs have subjects randomly assigned to different groups, which then each receive a different treatment. A crossover design is when a subjects receive both treatments, both the experimental and control or placebo treatment, in random orders with a break in between. Factorial design, 2 or more independent variables are investigated simultaneously. Pre-test, post-test control group design. Outcomes of 2 or more groups receive a pre-test, an intervention, and a post-test. Post-test only control group design. Outcomes of 2 or more groups receive an intervention and then just a post-test. Randomized controlled trial. Individuals are randomly assigned to experimental and control groups. Repeated measures design. Subjects are tested under every condition of a trial. This is also called a within subjects design. And a sequential clinical trial is when data is analyzed as it becomes available during a trial, and the trial is stopped as soon as sufficient data is collected. Different types of experimental controls. We have blinding. So single blind. These subjects are unaware of the hypothesis or which group they've been assigned to. A double blind. Subjects and some members of the research team are unaware of the hypothesis and which groups the subjects are in. So a common double blind is that both the subjects are blind and the PTs doing the measurements are blinded. And then a triple blind is when the subject, members of the research team, and the data analysis are unaware of the hypothesis and to which group subjects have been assigned to. Talking about control groups, active control is when an effective form of a treatment is used in place of placebo, as it is unethical to use placebo for comparison to experimental treatments when an effective active control exists. And then placebo control. Inactive substance or treatment is used the same way as an active substance or treatment. Internal validity, the extent to which an intervention being measured is the cause of the outcome being measured and not the result of extraneous factors. External validity, the extent to which an intervention being measured may be generalized to the public. The Hawthorne Effect tells us that subjects modify their behavior when they become aware that they're being observed. So you see the Hawthorne Effect every day in action when there's a cop sitting on the side of the highway. Whether or not he's actually using a radar gun, everyone slows down. People modify their behavior when they know they're being watched. Moving on to different types of hypothesis testing. We have the Alternate hypothesis, this is the experimental hypothesis, and the null hypothesis, this is the statistical hypothesis. P-values tell us the likelihood that a result could have happened by chance. So when you see p-value of 0.05, that implies there's a 5% chance that the data results could have happened from chance and not the interventions in the trial. The alpha level is the significance level. So this is just a different name for the number with the p-value. So in clinical research, it's almost always 0.01 to 0.05 at the maximum. Type 1 errors or alpha errors are errors that researchers make when deciding to reject the null hypothesis in error. So this is a false positive error. Type 2 errors or beta errors are errors that researchers make when deciding to accept the null hypothesis in error. So this is a false negative error. Statistical significance is a chance that is small that the difference between the groups after interventions happened by chance. Statistical power, essentially here, the more subjects in a study, the more power a study has. Effect sizes is the magnitude of difference between two different treatments. So larger effect sizes imply that the results are more likely to be statistically significant. Minimal clinically important difference, or MCID, is the smallest difference worthwhile to a patient's condition. This number is usually larger than the MDD, or minimal detectable difference, which is the minimum change beyond the basic measurement error. A few different types of graphs. A box and whisker plot illustrates the distribution of values into quartiles. So Q1 is the lower quartile, Q2 is the median, Q3 is the upper quartile, and then the maximum score is the final quartile. And outliers on a box and whisker plot are labeled as circles. A forest plot, you may have seen these in meta-analyses before. They show the results of individual studies. Each individual study is a square, and the proportion of the square is equal to the weight of a study. So a small square is a low power study, and a larger square is a higher power study. And then finally, at the bottom of a forest plot, the cumulative effect of all studies is displayed by a diamond. And there's usually a vertical line on a forest plot that demonstrates the line of no effect. So things to the left of the line had no effect or a negative effect, and things to the right had a positive effect. And finally, stem and leaf plots are graphical presentations of all the raw data of a study. So when you're looking at this data, you basically use something like the FOIL method. So the stem is on the left and the leaf is on the right, and you add each leaf digit to the stem to get a large pool of values. Descriptive statistics. Measures of center, the mean is the average. The median is the 50th percentile value, so the exact middle of the data set. And the mode is the value that occurs most often. Measures of distribution. The kurtosis is the name for the peak of the curve of a distribution. A normal curve is also called the bell curve. So 68% of all data falls within one standard deviation of the mean. 95% of all data falls within 2 standard deviations, and 99% of all data falls within 3 standard deviations. And skewedness is a way to describe the asymmetry of a curve. So negatively skewed means the mean and median are left of the mode with the left tail elongated, and positively skewed means the mean and median are right of the mode and the right tail is elongated. Inferential statistics. Beginning with parametric statistics, we have the analysis of variance, or ANOVA. A one-way ANOVA includes 2 or more population means with only one independent variable examined. A two-way ANOVA includes 2 or more population means with 2 or more independent values examined. Repeated measures ANOVA, all individuals and variables are examined, and regression analyses examine relationships between dependent variables and 1 or 2 more independent variables. Confidence intervals. The confidence interval is a range of values used to estimate the parameters of a population, with the confidence level being the probability that a confidence interval contains the population parameters we're evaluating. Point estimate is a single value calculated from a sample test and is an estimation of a population parameter. Correlation, we have the intra-class correlation coefficient, ICC. This assesses correlation and agreement among data. And the Pearson product moment correlation, or the R value, measures the magnitude and direction of linear relationships of data. T-tests, dependent and paired t-test, is a comparison of means of two correlated groups. An independent t-test compares two independent means, such as the difference between males and females. A one-sample t-test compares the mean of a sample to an expected mean of a population. This is helpful to make a decision if a sample differs from the population mean. A one-tailed t-test looks at deviations from the null hypothesis in one direction for consideration. So this tells us if an intervention had an effect, but only one effect if it was harmful or beneficial. And a two-tailed t-test looks at deviations from the null hypothesis in either direction. Each tail here is 0.025 or 2.5% of the significance. And finally, a z-test estimates population means when comparing two different means. The caveats here are that the population variance is known and that the population must have a normal distribution. A few nonparametric tests. Chi-square is a statistical test for nominal data that evaluates the difference between expected and observed frequencies. So remember that nominal measurements are values that are mutually exclusive and qualitative, such as blood type or eye color. A Kruskal-Wallis test examines if three or more independent samples occur within the same population. This is equivalent to a one-way ANOVA. And a Mann-Whitney test compares two independent samples of ordinal data. Remember, ordinal measurements are values that are ranked, like manual muscle test grades or levels of assistance. A Mann-Whitney test is equivalent to an independent t-test with parametric statistics. Statistical measurements of validity for tests and measures. We have sensitivity. So remember, sensitivity, negative findings are ruled out. There's a good mnemonic here, SN out, so snout. Sensitivity rules out. A test with high sensitivity rarely misses true positives. Specificity is that positive findings are ruled in. So a test with high specificity rarely misses true negatives. The mnemonic here is SPIN. Specificity rules in. You should always move from sensitive to specific tests to rule out things and then confirm your ruling in of a specific pathology or diagnosis. And finally, a little bit about epidemiology. Incidence is the number of new cases of a disease or condition during a specific time frame, while the prevalence is the number of existing cases of a disease or condition during a new time frame. So you can have those going on at once. You can have a prevalence of existing cases of a disease or disorder, as well as an increasing incidence or the number of new cases during the same time frame. That's it for episode 35, talking about evidence-based practice. This is the last episode of the podcast. As always, the outline will be in the show notes.